Welcome back to The Explainer. Today, we aren't talking about abstract computer models predicting what might happen in the year 2100. Nope. We are looking squarely at the very tangible, current-day impacts of climate change across our planet right now. We're going to use clear data and expert research to break down exactly what's happening in our atmosphere, our oceans, and our communities today. Let's just jump right in with a number: 20,000. Take a second to process that. During the summer of 2022, a brutal heat wave rolled across Western Europe. According to health agencies and researchers, that single heat wave killed an estimated 20,000 people. This isn't some future prediction. This is a stark reality grounding the climate issue in the present day. And scientists found that those kinds of temperatures would have been virtually impossible without human-induced global heating. And if that doesn't put things into perspective, try this one: 1.25 billion. That is the staggering estimated number of animals killed or harmed during the devastating 2019 to 2020 Australia bushfires. Between the loss of human life and the massive, almost incomprehensible destruction of ecosystems, the immense scale of these disasters is honestly becoming impossible to ignore. So, how are we going to unpack all this today? Well, here's our roadmap. First, we'll look at a world of extremes. Second, climate change's evil twin. Third, crumbling corals, empty shells. Fourth, sinking nations, burning lands. And finally, can we fix this? Let's get to it. First up, a world of extremes. Let's look at exactly how rising temperatures are altering our atmosphere. Global heating, which is driven mostly by the burning of fossil fuels, is fundamentally rewriting the rules of the sky above us. It's not just a thermometer ticking up a degree or two, right? It's about the chaotic weather patterns all that extra energy creates. According to researchers and the BBC, there are 4 clear ways human-caused warming intensifies our weather. First, the baseline shifts, giving us hotter, longer heat waves, like the UK hitting 40 degrees Celsius for the first time ever in 2022. Second, we get much more extreme rain. Third, changing global patterns cause longer, deeper droughts, like the catastrophic 5 failed rainy seasons we recently saw in East Africa. And fourth, extreme heat dries out vegetation, which basically acts like kindling, providing massive fuel for rapidly spreading wildfires. And the mechanics behind those deadly heat waves we mentioned, they often involve something called a heat dome. This happens when an area of high pressure stubbornly parks itself over a region for days or even weeks. It acts like a giant, invisible lid, trapping all this boiling air underneath it. And actually, some theories suggest that the rapid warming of the Arctic might be messing with the atmosphere jet stream, making these suffocating heat domes much more likely to happen. When you see images of first responders wading through chest-high floodwaters, this is why. For every 1 degree Celsius rise in air temperature, the atmosphere holds about 7% more moisture. It's simple physics, really. A warmer sky is a thirstier sky. But what goes up must come down. When all that extra moisture is eventually released, it results in extreme, unprecedented rainfall and flash flooding that completely overwhelms local infrastructure. Moving on to part 2, climate change's evil twin. Now we're looking at the chemistry changing our oceans. So pivoting from the sky above to the sea below, marine biologists and explorers investigating the deep actually have a pretty terrifying nickname for ocean acidification. They're dubbing it climate change's evil twin. As we pump more and more carbon dioxide into the atmosphere, the ocean acts like this massive planetary sponge, absorbing vast amounts of that CO2. But doing so literally changes the chemistry of the water, and it's creating a crisis that marine biologists consider an absolute emergency. Let's look at the numbers. Before the Industrial Revolution, the ocean's natural pH level was around 8.2. Today, it's decreased to about 8.05. Now, I know what you're thinking. On paper, that drop sounds tiny, but the pH scale is logarithmic. That seemingly small dip actually equates to a massive 40% increase in ocean acidity. 40%. And it's happening at a speed we have never seen before. All right, part 3, crumbling corals, empty shells. What is the biological toll beneath the surface? So what actually happens when you spike the acidity of the ocean by 40%? Well, you start to see some terrifying biological victims. Let me introduce you to a term: coral porosis. Think of it exactly like osteoporosis in humans, where bones become brittle and porous. This increased acidity literally dissolves the dead coral skeletons that live deep water reefs are anchored to. Scientists out off the coast of California are observing these deep-sea ecosystems, which are basically bustling marine cities, literally crumbling and collapsing under their own weight because the acidic water is eating away their foundations. And honestly, it gets even worse for the smaller creatures at the base of the food chain. Meet the pteropods. These are tiny swimming sea snails affectionately known as the potato chips of the sea, simply because everything from seabirds to Alaskan salmon eats them. Scientists at London's Natural History Museum actually compared modern pteropods to historical samples collected by the HMS Challenger way back in 1875. The findings? Modern shells are up to 76% thinner. The acidic ocean is literally dissolving their shells while they are still alive, which threatens the entire global seafood supply chain, and yeah, that directly impacts the food on our plates. Which brings us to part 4, sinking nations, burning lands. Let's dig into the human and economic costs. Bringing the science back to dry land for a minute, one of the biggest drivers of human displacement right now is rising sea levels. And this is driven by two main factors. First, you have higher global temperatures melting polar ice and glaciers, which dumps massive new volumes of water into the ocean. Second, and this is a big one, is thermal expansion. It's a simple physical reality. Water actually increases in volume and takes up more space as it warms up. To put a human face on this, look at the Pacific island nation of Tuvalu. We are witnessing the total dismantling of a society in real time. Socially, 4,000 residents have already emigrated, and the entire nation will likely be forced to relocate by 2050. Economically, coastal flooding threatens their main airport runway, which cuts off crucial travel and trade, forcing them to rely on incredibly expensive imported food. And environmentally, rising saltwater is intruding inland, destroying their crops and poisoning underground freshwater supplies. It's a complete systemic disruption of a whole country. And these extremes, they hit massive continents just as hard. Let's revisit the Australia bushfires of 2019 and 2020. The numbers here are just staggering. 57 billion pounds in property damage and economic loss, 186,000 square kilometers burned. To put that in perspective, that's an area larger than the entirety of England. 5,900 buildings destroyed, and tragically 34 human lives lost, including 4 incredibly brave fighters. It's really no surprise that this kind of widespread, tangible devastation has sparked massive global protests. Citizens and organizations all over the world are taking to the streets. They're demanding that planetary health be prioritized over corporate profit and urging their governments to enact immediate reductions in greenhouse gas emissions. Finally, part 5, can we fix this? Let's explore some of the potential solutions we have on the table. Look, I know this data is incredibly heavy, but we can't just stop at the doom and gloom. Experts outline a multi-pronged approach to mitigate this crisis before it's too late. Step 1 is the absolute, non-negotiable prerequisite, drastically and immediately reducing fossil fuel emissions. We simply have to stop putting the carbon into the air to begin with. Step 2 is leveraging the brilliance of nature. For example, planting underwater seagrass, which naturally captures carbon up to 35 times faster than tropical rainforests. And Step 3 involves investing heavily in brand new, innovative technologies. Speaking of new tech, a massive target for innovation is the ocean itself, especially since it holds 150 times more CO2 than the atmosphere. There's a company that just built a novel direct ocean carbon capture facility out in Hawaii. Right now, it's capturing about 37 tons of CO2 per year at a cost of $475 per ton. But their ambition? It's huge. They want to scale this up massively and literally filter the ocean until they restore it back to pre-industrial pH levels. Which leaves us with a pretty profound, if slightly sobering thought from the researchers. The point at which we could have avoided the worst of this car crash of a climate crisis. Well, that's over. We've hit the wall. The damage is here, and as we've seen, it's very tangible. But we still have our hands on the steering wheel and we still have our foot on the brakes. So the question I want to leave you with is this. How do we make this crash survivable? How is our society going to adapt, fund, and actually implement these solutions before it's too late? Think about that for a bit. Thank you so much for joining me on this explainer, and keep learning.